Welcome. Today we take a new chapter for discussion. Chapter is coordinate system and straight lines in two dimensions. And all problems are for preparation of joint entrance main, advanced, and for different state level joint entrance examination. First of all, I tell you frankly that this chapter is rather easier. In fact, coordinate geometry is rather easier, but it is little bit lengthy. So it requires a lot of practice. So I first define a actually I first define uh, gradient of a straight line. Suppose these are x-axis, y-axis, and a straight line is like that, straight line. Gradient of the straight line is simply if it makes an angle theta with x-axis, positive direction of x-axis, then tan theta is gradient of the straight line. And normally we denote it by m. M stands for normally gradient. Mind that if theta is the angle with positive x-axis and the straight line, this is tan theta will be gradient. Even if we know 2 points on the straight line x1, y1 and x2, y2, then gradient of the straight line M is equal to difference of y coordinate y2 minus y1 by x2 minus x1. That is difference of y coordinate in numerator, and in denominator difference of x coordinate. So from this or from that we can obtain the gradient of straight line. Okay, next, there are so many formula, and from any standard book you can collect it and you have to keep in memory. Suppose this is a straight line. A is a point x1, y1. B is another point x2, y2. And C is a point in between them, C, whose coordinate is say capital X, capital Y. Then, and such that C, point C divides AB internally in the ratio m is to n. This m is not is equal to that. M is any constant, m and n. Then coordinate of C, that is capital X, x coordinate, it is m into x2 plus n into x1 by m plus n. It is in fact m, this section, this ratio multiplied by x coordinate of the other a, and n into x1 divided by m plus 1. If C is the point outside AB, then that is externally, C meets AB externally in the same ratio m is to n. M means from this to that it is m, and n is from this to that. In that case, In that case, x is equal to mx2 minus nx1 divided by m minus n. And in same way, capital Y, that is y coordinate of the point C, which divides AB externally in the ratio m is to n, is m y2 minus n y1 by m minus n. For case of internally bisector C, x coordinate is this, y coordinate is same as that. Instead of x, we have to put y. That is my2 plus ny1 by m plus 1. Next, our next point is area of a triangle having coordinates xi, yi. I is equal to 1, 2, 3. Means, suppose A is a point x1, y1, B is a point x2, y2, C is point x3, y3. Then area of the triangle is, it is normally denoted by delta, half the modular sign into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x1 into y2, sorry, x3 into y1. This is not x1. x1, x2, now x3 into y1 minus y3 and closed. But actually, it is a formula you can keep in mind, and it is a very simple formula because in every case there are two factors. In three terms are there, two factors in every term, this and that. First one is first coordinate of x coordinate of A, that is x1 into, then it is y2 minus y3, 1, 2, 3. Next one is x2, that is x coordinate of the second coordinate, x2 into, then y3, y1, 2, 3, 1. And similarly x3 into y1 minus y2. That is between 1, 2 and 3, 1, 2, 3, 2, 3, 1, 3, 1, 2. Cyclicness is there. Acha. Or if you cannot keep in mind it, then you write the coordinates x1, y1, first coordinate, that is the coordinate of A, then x2, y2, x3, y3. Now repeat the first one, x1, y1. Then area of the triangle is half into modulus of, multiply this with that, then this with that, then this with that, and add them. That is x1, y2 plus x2, y3 plus x3, y1. Then put a negative sign, and after that you take this product, y1 into x2, y2 into x3. It is y1 x2 plus y2 x3 plus y3 x1. Modular sign. Modular sign because area cannot be negative. That's why. I think uh, this is very simple way. Formula is also simple. Anyone you can keep in mind. Similarly, area of a quadrilateral. Suppose any quadrilateral is like that. A, B, C, D, and coordinates are xi, yi. I is equal to 1, 2, 3, and 4. So simply you can divide the quadrilateral into two triangles by joining any two opposite vertices. Now you can find ABC, area of ABC, give a modular sign, take positive sign, and then find area of ACD, give a modular sign. And then this would be the area of the quadrilateral. Or you can keep in mind that the formula area of the quadrilateral is modulus x1 y2 plus x2 y3 plus x3 y4 plus x4 y1 minus y1 x2 plus y2 x3 plus y3 x4 plus y4 x1 square units. This would give you a area of the quadrilateral. Next, centroid of a triangle. Centroid means if you draw, this is a triangle, midpoint, midpoint, this is midpoint, this is always, this one is A to A, B, C, midpoint D, E, F. Now, these must meet, for any triangle, these must meet at a single point. That point normally denoted by G. Medians, meeting point of the medians is the centroid, and its formula, coordinate of the centroid is x1 plus x2 plus x3 divided by 3, comma, y1 plus y2 plus y3 divided by 3. This is coordinate of the centroid of the triangle ABC, and A is coordinate of A is x1 y1, x2 y2, x3 y3. Next, incenter. Let us see what is the incenter. For any triangle, say, just 1 minute. Suppose this is a triangle. Internal bisector of this, internal bisector of that, and internal bisector of this angle, they also meet at a single point, and that point is called incenter. If A is equal to x1, y1, B x2, y2, and so on, then incenter, coordinate of incenter is A into x1 plus b into x2 plus c into x3 by a plus b plus c. And y coordinate same, a into y1 plus b into y2 plus c into y3 divided by a plus b plus c. Here ABC, these ABC, actually small a is the side, length of side opposite to capital A. Similarly, small b is length of side opposite to capital B, and this is small c. Then this would be knowing x1, y1, x2, y2, x3, y3, and the length of sides. Very easily, using this formula, we can obtain the in-center of the triangle. One very important tip for competitive examination is that in any triangle ABC, its orthocenter, normally denoted by O, centroid, normally denoted by G, and circumcenter, normally denoted by C. For any triangle ABC, orthocenter, centroid G, and circumcenter C, these 3 points are always collinear, and G divides OC internally in the ratio 2:1. G divides, this is O, this is C, and this is G. Divides, this is G, 2:1 in the ratio, internally in that ratio. So once again, what is orthocenter? Orthocenter is from vertex perpendicular is drawn to opposite side. This way, from B, draw perpendicular to opposite side. From C, draw perpendicular to opposite side. These 3 perpendiculars must meet at a point, and this is known as orthocenter. Normally, it is denoted by O. Centroid. Centroid I have discussed. Circumcenter. Circumcenter is, for a triangle ABC, a circle is drawn passing through the vertices A, B, and C. Its center is called circumcenter of the triangle ABC. So, very important point is that orthocenter, centroid, and circumcenter, these 3 points always are collinear. And G, this point G, divides orthocenter and circumcenter in the ratio 2:1 and 2:1 internally. So, knowing this formula, when orthocenter, between orthocenter, circumcenter, and centroid, 2 will be given, and from there we have to find the other one. Using this formula, very easily it can be obtained. Next important point to discuss is that for any right angle triangle, the vertex containing the right angle is the orthocenter of the triangle, like this. This is a right angle at B. Perpendicular is drawn to BC. From A to BC, it is AB. Perpendicular from C to AB, it is CB, and from this to that perpendicular. These three perpendiculars meet at a point. Which point? It is a vertex containing the right angle. This also very important. Sometimes it is one triangle will be given, which is right angle triangle. Find orthocenter. So if we can somehow manage that it is a right angle triangle, then the vertex containing the right angle is the orthocenter of the triangle. Next, for polar coordinate. In any coordinate system, suppose this is initial line and a point is there, say a point A. This is pole, this is O. The point is at a distance, say R from the pole, and it makes an angle theta with initial line. Then R comma theta is the polar coordinate of the point. It is initial line and this is pole, and coordinate of A is R comma theta. What is R? Now, R is its distance from the pole O. And what is theta? Now the straight line makes an angle theta with that initial line. Then it is R theta. Now suppose 2 points A and B are given in polar coordinate. One point is A, R1 theta 1, and B, R2 theta 2. Then distance AB in terms of polar coordinate is AB is equal to root over of R1 square plus R2 square minus 2 R1 R2 cos of theta 1 minus theta 2. Area of the triangle in polar coordinate. Suppose ABC is the triangle, coordinate of A is R1 theta 1, coordinate of B is R2 theta 2, and coordinate of C is R3 theta 3. Then area of the triangle in polar coordinate is half modular sine into R2 R3 sine of theta 2 minus theta 3. If it is R2 and 3, R2 R3 sine of theta 2 minus theta 2 minus theta 3 plus R3 R1 into sine of theta 3 minus theta 1 plus R1 R2 into sine of theta 1 minus theta 2. Modular sign, because it cannot be negative, area cannot be negative. More or less, these are the standard formula, and if there is something new, I tell you in course of solving problems. Next, straight line. What is straight line? Definition of straight line, I think you know it. Any equation involving x and y, linear equation involving x and y, like ax plus by plus c is equal to 0, This is equation of any straight line always. It has few forms like y is equal to mx plus c. It means this is first degree equation and m, c they are constants. Here also a, b and c are constants. First degree equation, it represents a straight line which meets y axis at a distance c and its gradient is m, means if it is theta, m is equal to tan theta. It means if for a straight line, two things, excuse me, two things are known. One, the angle which it makes with x-axis and the intercept where it meets y-axis. If these two things are known, then y is equal to mx plus c is the equation of the straight line whose gradient is m and whose y-intercept, মানে intercept on y-axis is c. Mind that here in left hand side y coefficient of y is 1, y is alone, and in right hand side coefficient of x would be the gradient and the constant term will give you the y intercept. Next, y so next one is a equation of a straight line passing through x1 y1 and making an angle theta with x-axis, that is m is equal to tan theta, then y minus y1 is equal to m into x minus x1 would be the equation of straight line. Mind that here it is an equation involving x and y, linear equation. M is constant, which is gradient of the straight line, and x1, y1, they are a point passing the known point, like that. Suppose this point P is x1, y1, and it makes an angle theta with x-axis. Then its equation is y minus y1 is equal to m. M means tan theta into x minus x1. Or m, otherwise we can obtain m. Anyway, these are two very important formula. Third one is, suppose a straight line is like that. It makes an intercept A with x-axis and B intercept with y-axis. Then its equation is x by A plus y by B is equal to 1. It will help you to draw this straight line very easily and quickly. Like say x by 2 plus y by minus 3 is equal to 1. It means x-axis, it meets the x-axis at a distance 2 and y-axis at a distance minus 2. Minus 2 means on negative y-axis, like that. X-axis, it meets x-axis at a distance 2 and y-axis at a distance, this is y negative, this one, this is y positive, it is 3 in negative direction. And knowing this, we can very easily draw the straight line, because the straight line we have to draw it. So take 2 0 point on x-axis and minus 3 0 a point on y-axis, join them. Next, suppose we are given an equation like that. Say 2y plus 2x plus 3y is equal to 12. What is gradient of the straight line? Question is that. What is gradient of the straight line? Now you make it to that form, y is equal to mx plus c. Means we have to find y alone. So 3y is equal to minus 2x plus 12. So y is equal to minus 2 by 3 into x plus 4. It means y is equal to mx plus c. So that gradient of the straight line is minus 2 by 3. That is tan theta is equal to minus 2 by 3. Theta is here obtuse. And it makes an intercept of 4 unit from y-axis. So from this equation, we obtain to that equation, or it is question, draw the straight line. You try to make it to intercept form. So divide it by 12, and intercept form is x by a plus y by b is equal to 1. That is, right hand side is 1. So divide by 12, x by 6 plus y by 4 is equal to 1, by dividing by 12. So that it is very clear that it is a straight line. It makes an intercept of 6 unit positive, 6 unit on x-axis, and 4 unit on positive 4 unit on y-axis. So now very easily you can draw it. 4 unit in 40, and it is say 06. 6 unit on y-axis. Join them. Extend. This is the straight line that or that. It's okay. Let us stop today. Next day we discuss few more important points, then solve problems. Before that, I request you to please subscribe my channel, and you like it and share it with your friends. Thank you.